organic topics rather than other inorganic topic. This topic is very important. Very important topic it is. That's why whenever we are preparing for this one, the inorganic chemistry, as we are having the first preference in this one, the NEET related with organic, and the second preference will be given for what? Second preference is related with inorganic, and the third is related with what? Or third is related with physical section. That's why whenever we are dealing with this one, always we can understand that whenever we are going with respect to the topic, we need to prepare on the basis of marks, children. Don't prepare in a haphazard way like this one. Just we have to concentrate on the topics which carries more marks. Okay, let us start with the topic chemical bonding and molecular structure. Chemical bonding and molecular structures. Chemical bonding and molecular structure. Chemical bonding and molecular structure. So as I said that the NEET pattern, if you'll see, the major part from the inorganic section is covered by this topic, chemical bonding and molecular structure. And in this topic as a whole, what we have to discuss that why there is a formation of a chemical bond. Why there is a formation of a chemical bond? What are the reasons to get a chemical bond? And here, what are the conditions to get a chemical bond? Whether all the bonds will be same or different. Remember here, when the bonding atom like the interatomic and intermolecular will decide what type of bond can be obtained. Other than that, even we have to consider related with the different types of the bond, their conditions, characters. Many theories are there, like the valence bond theory or the Langmuir, this one, the Lewis theory, and as well as VSEPR theory and molecular orbital theory. Here we are having 4 important theories are there where we can expect maximum question. Other than that, the major part of this topic, they have concentrated much on hybridization, even on the bond parameter, even depending upon the representation of the resonating structure and the formal charge. As a whole, topic is good to read, and as well as the topic is, when it is a scoring, we need to prepare well. Correct? And for this weekly test, we are going to complete up to VSEPR theory. As already we have posted the syllabus to you, let us start with chemical bonding and molecular structure. Before going to the topic, let us see that what is a chemical bond? What do you mean by chemical bond? What is the meaning of chemical bond? Have you observed that the two species or the constituent atoms or the constituent particles, they are held together by a bond. They are held together by what? By a bond. Now the question arises that what is a bond? Now the question arises that what is a bond? And when we are considering the bond, always we should see that the bond will be consist of what? It will be the attractive force. Bond will be what? Attractive force. It will be a force of interaction, or we can say that it is an attractive force. Bond is, chemical bond can be defined as the attractive force. Attractive force which holds constituent atoms. Which holds what, children? Constituent atoms or ions. Constituents may be atoms, may be ions, or they may be molecule. They may be molecule together. Or even we can call it as, even we can treat it as, one more way we can call it as the union of constituent particles. Union of constituent particles. Union of constituent particles are also called as a chemical bond. When you are defining a chemical bond, we can see that the chemical bond can be defined as the force of interaction, or we can say that the two bonding species, or they may be atom, they may be molecule, they may be ion, they are held together by some interactive force. Some force of interaction will be there, which are responsible to make them to exist together. They are called as what? A chemical bond. And here, all these reason why it is so. The reason to get a chemical bond is to attain minimum energy. Okay. The reason is that the reason to get a chemical bond. Reason. What are the reasons are there? There are two important reasons are there. First reason that molecule wants to attain minimum energy. They should attain minimum energy. Molecule must attain what? Minimum energy. Minimum energy. They must attain minimum energy in such a way that minimum energy will be most stable. Minimum energy is nothing but what? They are having high stability. They are having high stability. This is one of the reason. And the another reason that, and when they have electronic configuration of noble gases, they want to attain what? Noble gases electronic configuration as ns2np6 electronic configuration. This is also most stable. Yes. So it means that to get a chemical bond, there are two important reasons are there. One, what it is? To attain a minimum energy, or to gain more stability, or to attain noble gas electronic configuration as ns2np6. These two are the major reasons which makes the molecule, which makes the constituent particles in a molecule together. So here, as in the earlier days, in the old ancient days, what they thought that the scientists have treated noble gases elements as like the standard for them. They have treated the noble gases as standard element because they are having completely octet structure. Listen my sentence properly. What I said, they are having octet. Octet is nothing but what? 8 electrons. And when they are having 8 electrons or the octet structure, their stability, they are more stable as compared to other elements which are partially filled. That's why they have treated the noble gases as standard elements for them. They have considered it as what? Standard elements for them. That's why whenever they are going to get a reason for formation of a bond, and the cause for the formation of a bond, and as well as to attain the octet structure. This is the main concept. Actually, in the whole topic, the major part is covered with octet configuration. Octet configuration means what? Where they are containing 8 electrons. When they are containing outermost as 8 electron, they are more stable. What they are? More stable. And during always the formation of a bond, always in any formation of a bond, attractive force must be greater than repulsive force. Attractive force must be greater than repulsive force. Then only we can expect a bond formation. Then only we can expect what, children? Bond formation. Otherwise, we cannot expect the bond formation. If it is a reverse, like the repulsive force will be greater than attractive force, we cannot expect the bond formation. Now, to explain about the stability of 8 electron, the Cossell and Lewis has proposed a theory called as Cossell-Lewis approach also we can say. We can also call it as what? Cossell-Lewis approach, or we can say that these are the approach to form a covalent bond formation, or we can say that Cossell-Lewis approach for chemical bonding. We can write here. Afterwards, we can recall all one by one. That's why we'll move to this one. So what we can say? Cossell-Lewis approach. Coasel-Lewis approach. Coasel-Lewis approach for a chemical bond. Coasel-Lewis approach for what, children? For a chemical bond. Coasel-Lewis approach for chemical bond. This is also called as even we can call it as what, children? We can call it as octet rule. We can call it as octet rule. Octet rule. As we know very well that octet represent what? 8 electrons. Octet represent what? 8 electrons. 2 persons are there, Coasel and Lewis. Coasel and Lewis have worked together to see that how the electronic configuration with NS2 NP6 they are stable. Because as I said earlier to you children that noble gases they have treated as water, they have treated as standard element. That's why Coasel-Lewis approach said that inert gases like the noble gases, they cannot combine with each other, even they cannot combine with others and as well as with themselves. We can say that according to the Coasel-Lewis approach or according to octet rule, they said that inert gases are, or we can say that neither they can combine together or with other. They said that the inert gases, according to Coasel and the Lewis approach, inert gases are do not combine. Inert gases do not combine with each other and as well as, remember here, they cannot combine with themselves and as well as with other. That's why they are treated as what? Inert. Inert is nothing but what, children? Inactive. Inert is nothing but what? In a simple language, we can call it as inactive. They don't have tendency to combine with other because when they are attaining the electronic configuration, why it is so? If the question is arises to us, we can say that when they have the electronic configuration NS2, NP6, why they'll take a chance to combine with other? It means that they themselves are stable. We can say that they themselves are stable and that stability makes them inert. And that stability is for what reason? Because of octet. Because of octet. 8 electrons are there. Correct? But remember here, all the molecule cannot obey every theory. That by keeping that in the mind, we can move, children. So we can say that according to the Coasel-Lewis approach, what they said that inert gases chemically, they do not combine with other element and as well as among themselves. And that is due to what? 8 electrons or the, we can say that NS2, NP6 electronic configuration. And the any element which has the electronic configuration equals to noble gases, it means that they are obeying octet rule. What does it mean, children? It means that they are obeying octet rule. Correct? When they are obeying the octet rule, what does it signifies? As we said over here, this is the reason already we said at the time of bond formation also. Now let us see that what are the significance of Lewis symbol? What is the significance of Lewis symbol? That symbol also we'll see, children. Significance of Lewis symbol. Significance. Significance of Lewis symbol. This is most important part of the topic because what the Lewis said that number of valence electrons, listen my sentence properly, number of valence electrons will be equal to number of atoms, number of dots on individual atom or individual element. Individual element, okay? Individual element. On individual element, what we are representing a dot, because according to the Lewis dot theory, even we can call it as what? Lewis dot theory also you can call, or you can call it as Coasel and Lewis approach. They said that every element, okay? every element, whatever the number of valence electrons are there, those many number of dots must be represented. Those many number of dots must be represented. If we are going to take the example, hydrogen has only one valence electron. That's why hydrogen can be represented by with what? One dot. Correct? Is it visible now? Yes, I am representing with a different color. It will be easy for you to understand. 1 minute. Okay, I'll take with, okay, one dot. Another way, visible or not? Yes, it is visible. Another way we can say that when we are considering the lithium atomic number is 3, 1s2, 2s1. Therefore, number of valence electrons are again 1. If we are going to take the example like beryllium, atomic number 4, 1s2, 2s2. Shall I write here electronic configuration also? This we can write it as 1s1. This will be 1s2, 2s1. Correct? 1s2, 2s2. Therefore, we can write by mistake one dot has come. Beryllium 1s2, 2s2. I'm writing valence electron. I'm not writing complete this one because already you are familiar with electronic configuration. Therefore, we can write the number of dots as 2. Same way if you are going for boron. Boron atomic number 5. 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. I'm writing valence as I said that. That's why around the boron, I can write 3 dot. Around the boron, how many dot I should write? 3 dot over here. Same way we'll write up to 1 this one. Hydrogen, lithium, beryllium, boron. Then we can write carbon. Carbon contain 1s2, 2s2, 2p2. So carbon contain how many valence electron? 4 electron. Then we'll take nitrogen. Nitrogen 1s2, 2s2, 2p3. So around the nitrogen, 5 must be present. Okay, 5 valence electron must be present. Same way with respect to oxygen. 1s2, 2s2, 2p4. 1, 2, 3, 4, 5, 6. Correct? Similar way we can write with respect to what, children? With respect to the fluorine. With respect to fluorine, as they are having 7. 1, 2, 3, 4, 5, 6, 7. Correct? Similar way with neon as 10. Neon, how many valence electrons are there? All are fulfilled, but number of valence electrons are 8. That's why you have to write 8 electrons. 8 electrons, or we can represent it by a dot. Now the question arises that what does the significance of Lewis dot I said? Okay, what I said that what are the significance of Lewis dot? Lewis dot represent what? Number of valence electron. It is visible now. Dot I'm representing with violet color, and this is I'm writing with the red. It will be easy for you to identify. So here we can say that number of the valence electron are equal to number of dots I said. Number of dots on individual element. Individual element we are representing by a dot. It represent the main point. Will come to the main point that it represent number of valence electron, and number of valence electron represent what? Valency of individual element or the combining capacity of an element. We can call it as what? It represent combining capacity of an element. It represent what? Number of valence electron. Even the number of valence electron helps to calculate valency. Valency is nothing but what, children? Combining capacity. Valency is nothing but what? Combining capacity. Later after this one, when we'll go for the covalent bond formation, again we'll continue this theory. So here, significance of Lewis symbol. Lewis symbol has 2 important significance. One, with respect to number of valence electron. Number of what? Valence electrons. And the second significance, valency. Valency of respective group. Valency of respective group, or in general we can call it as what? Combining capacity. Combining capacity. This is the 2 main significance of what? 2 main significance of Lewis, or we can say that Lewis approach for a chemical bond formation. For a what? Chemical bond formation. Now the next point arises that all these, whether the bonding atoms are there or the molecules are there, ions are there, how they are going to form a bond? Remember one thing, they can form a bond always in two ways. Okay, one, by sharing of electron, correct? Second, by transfer of electron. What I said, that there will be a mode of how they are going to share the electron. Because when we are dealing with water, when we are dealing with what, children, on the basis of the octet atom, we said to attain the octet electronic configuration, or we can say that to attain the ns2 np6 electronic configuration, either they will follow the path by sharing of electron, or they will follow the path by transfer of electron. We can say that to attain noble gas configuration, we can write here to attain. I'll write here to attain yes, to attain octet. To attain octet, they will be involved in bonding. In what way? Either they will take by transfer of electrons, by transfer of electrons. Transfer of electron leads to which bond? Ionic bond. Transfer of electron leads to ionic bond, or by sharing of electrons. And this sharing of electrons will be of again two types. Sharing of electrons will be of again two types, either by mutual sharing, of electrons. Mutual sharing of electron leads to what? Covalent bond. Mutual sharing of electron leads to what, children? Covalent bond. Or only one constituent atom will be involved in sharing. Remember here, mutual sharing means what? Good understanding between the two. Mutual sharing is nothing but what? Good understanding between the two. Or sharing of the electron pair, contributed by only one of the atom. Sharing of electron pair, contributing by only one of the element, only one constituent particle. Only one constituent particle, and that leads to what? Coordinate bond. That leads to what? Coordinate. Covalent bond also will call. That leads to what? Coordinate bond. Because of this sharing word only, they are calling it as coordinate covalent bond also. So what I said, that Lewis dot said that how many number of valence electrons are there? Those many number of dots you need to represent. And it signifies number of valence electron, and as well as it signifies what? Valency of individual group over there. Valency of individual group. If we are taking that to attain octet electronic configuration, that can be done in two ways, either by transfer of electron or by sharing of electron. Transfer of electron always leads to what? Formation of a ionic bond. Transfer of electron leads to what? Always there is a formation of a ionic bond, whereas sharing of electron, it may be a mutual sharing, or it may be sharing from only one side. It may be a mutual sharing of the electron, or only one species will be involved in sharing. That's why we said that sharing of the electron contributing by only one constituent particles. So like that, they are going to form what? A bond. When they are going to form a bond, what are the different types of the chemical bond are there? That we'll see one by one, children. Okay, that we'll see the types of chemical bond. There are the different types of chemical bond are there. We will write one by one. Types of chemical bond. types of chemical bond. And this chemical bond is of two types. Maybe interatomic, or it may be intermolecular. Interatomic, maybe intermolecular. In that interatomic, it may be a covalent bond, it may be an ionic bond, it may be coordinate covalent bond. Okay, it may be metallic bond also. So here we can say that when we are dealing with the interatomic, they may be covalent bond, ionic bond, coordinate bond, or metallic bond. In case of the intermolecular, they may be hydrogen bonding, or they may be van der Waals force. They may be van der Waals force. So it means that to get a chemical bond, what we said that either by transfer of electron or by sharing of electron. In the case of the sharing of the electron, what I said, here in the case of the mutual, the sharing of electron can take place mutually, or one is going to contribute whole part over there. One is going to just to the donor and other will be simply acceptor. That also leads to the formation of a chemical bond only, but it is a coordinate covalent bond. Now we'll see what are the types of the covalent bonding. Sorry, what are the types of the chemical bonding. In case of the chemical bond, can be obtained between interatomic, correct? Between atoms of a molecule, we can say, or here between intermolecular. When it is interatomic, it may be a covalent bond, ionic bond, coordinate bond, it may be a metallic bond. Whereas intermolecular bonding will be hydrogen bonding and weak van der Waals force. Amongst all, the weakest bond present over here is what, children? It will be a van der Waals force. Van der Waals force are nothing but what? It will be held by a weak van der Waals force. The best example we can take it as noble gases. All the noble gases are held by weak van der Waals force. That's why they are having very low boiling point. Because of this reason only they are having very low boiling point. And as per this one, as per our syllabus, we have to discuss all these individual. Correct? Many theories are there in between. But if we'll see the whole topic, covalent bond, ionic bond are little bit in detail part, whereas the remaining three are just we are having the examples related with that respective bond. Let us move to the first one, that is a covalent bond. As I said just now, the covalent bond is obtained by what, children? It is obtained by sharing of electrons. Let us write here covalent bond. Covalent bond. Covalent bond is obtained by mutual sharing of electrons, we said. Both are going to share equally. Means both are going to share equally. For example, A also carries one valence electron, whereas a B also carries one valence electron. Depending upon the situation, A can take up both the electrons or B can take up both the electron. Okay, that leads to the formation of what? That leads to the formation of a chemical bond. So here, that chemical bond is called as covalent bond. In a simple way, later we'll go to the individual example, children. In that case, we'll take homomolecule also, a heteromolecule also, even we'll see molecular ion. But let us see what are the conditions and all. After that, we'll go for the example. So here, covalent bond is obtained by mutual sharing of electrons. Okay, there are different theories are there. Different theories are there which have been put forwarded the formation of a covalent bond. One is what? Langmuir theory. One is the Langmuir theory is there, and the second theory is related with the valence bond theory, and the third theory is related with what, children? Third theory is related with molecular orbital theory. Third theory is molecular orbital theory. Therefore, the first theory, there are the theories, different theories are there. The first one is Langmuir. Langmuir-Lewis theory also you'll call. Langmuir-Lewis theory. And the second is valence bond theory. And the third is molecular orbital theory. These are the three important theories are there which have come forwarded to explain about formation of a chemical bond. Maybe homomolecular, maybe the heteromolecular, they may be a molecular ion also. Molecular ion, when we are dealing, it may be a cationic or it may be anionic also. It may be anionic also. Let us move to the first theory, Langmuir-Lewis theory. First theory, let us move to the first one, Langmuir. Langmuir-Lewis theory. Correct? What we said that on the basis of the chemical bond, always the bond can take place between a water. Bond can be takes place by the sharing of electron. By the sharing of electron. And before going to the theory, once again, let us see that what are the conditions are there. Okay. What are the conditions are there to get a covalent bond? Let us move to the theory. After that, conditions. After that, again, we'll come back to this one. Okay. Conditions to get a covalent bond. Conditions. Because once we'll start one theory, we'll complete all the theories together. That's why first we'll complete conditions and characters of covalent compound one side, then we'll go to the example. So here conditions are there for to form a covalent bond. To form a covalent bond. What is the first condition? Number of valence electrons. The first condition that number of valence electrons. Number of what, children? Valence electron. Whenever the two bonding species are involved in what? A covalent bond formation. They should contain what? 5, 6, or we can say that 7. 7 valence electron. Easy to become octet by sharing of 3, 2, and 1 electron. Listen my sentence properly. The first condition to get a chemical bond, covalent bond is number of valence electron. Number of valence electron, what? Each atom should have 5, 6, 7 valence electron. It will be easy to share 3, 2, 1 to become octet. Have you understood my sentence? Yes, I'm repeating the sentence. The number of valence electron is the first condition. We said that each of the atoms should have 5, 6, or 7 valence electron in such a way that both can achieve octet by sharing with 3 to 1 electron. 3 to 1 electron. And the second condition, they should have equal or very less difference. Very less difference in electronegativity. In what, children? Electronegativity. Difference must be very low in electronegativity. Even that case also they can form a bond. In that case also they can form a chemical bond. Correct? And the third one, they should have high ionization enthalpy. High ionization enthalpy means what? Neither one should lose the electron. Correct? They are not getting the chance to lose the electron. They should have what? They should have high ionization enthalpy. High ionization enthalpy. Neither of two can lose the electron readily or easily. And the last is mutual sharing. As we said the definition, same condition we can write here. Both should have mutual understanding, mutual sharing of electrons. mutual sharing of electrons. So these are the conditions are there to get a chemical bond. To get a chemical bond, what are the conditions are there? Number of valence electron contributed, number of valence electron of individual atom must be what? Individual element involved in the bonding must be what? 5, 6, 7, so that they can share with other element. They can share with other element to form a octet by sharing of how many electron? 3, 2, 1. And the second, they said that electronegativity difference between the two must be equal, or it will be very less difference. It will be what? Very less difference. And the third point, we said that they should have high difference, high ionization enthalpy. It means that neither should lose the electron, because we are expecting what? A covalent bond which is obtained by sharing of electron. And the last one is mutual sharing of electron. This is the utmost condition. This is the most important condition. Then only we can expect a formation of a chemical bond. Then only we can expect what? A formation of a chemical bond. Now the question arises that what are the characters of covalent bond? What are the characters are there? We know very well that covalently bonded molecules are non-polar. Yes, they are non-polar, and when they are non-polar, they are insoluble in water. They are insoluble in water. That's why whenever we are writing the characteristics of a covalently compound, they are usually exist as gases or solid. Shall we write here? In inorganic, one of the two exceptional cases will be there. Correct? You may be thinking that diamond, as I said just now, the physical state, they will be exist as gases or the liquid. We will write one by one. They are non-polar. Correct? They are non-polar, but you can expect like the HCl, which is a polar in nature. Exceptional cases will be there in inorganic chemistry. Based upon those exceptional cases only, we can expect the question. Other way that most of them will be exist as gases or solid, gases or liquid, but we can take the example like carborundum, silicon carbide, or the diamond, or even we can consider silica. All these are what? They are exist in solid state. They are exist in solid state. When they are non-polar, they are insoluble in water. They are insoluble in water. And almost all of them, they are what, children? They are having low melting point. Remember here, as we said that they are obtained. The bond is obtained by sharing of electrons. That's why all these are having low melting point and low boiling point. Low melting point and low boiling point. When they are non-polar, they are insoluble in water. They are insoluble in water. But here I can write, in case of the non-polar, what I said that we are having one of the example like the HCl, which is a good conductor also. HCl, which is a good conductor. But as we said just now, most of these are not conductor. They are insulator. But exceptional cases will be there. We can say that they are not the good conductor of electricity, but some exceptional cases are there. They are showing good conductivity. So these are about the characters, or we can say that what are the nature of the covalently bonded molecule. As in the syllabus, we have completed whole organic chemistry. We said in total general properties, we have written many times that lower hydrocarbons are gases, higher are liquids and the solid, we said. Very exceptional cases when we are dealing with lower are soluble in water. Even we said the reason, due to formation of a hydrogen bonding. Maybe inter, maybe intra. They are having the character to undergo formation of a hydrogen bond. And when they are involved in hydrogen bonding, then only we can expect what? A solubility. Then only we can expect what, children? Solubility. So these are, this one are there. Now let us move to the theories of the covalent bond in detail, children. Theories of covalent bond. Let us move to the first theory, that is what is a theory? Lewis-Langmuir theory. Let us move to the first one. Lewis-Langmuir. Lewis-Langmuir theory. Lewis-Langmuir theory. According to Lewis-Langmuir theory, they said that whenever there is a formation of a covalent bond formed by the mutual sharing, or they said that mutual sharing, either by mutual sharing or sharing contributed by only one species. Both are called as covalent bond. That you need to remember. One will be the donor, one will be the acceptor. That's why they are treated separately as coordinate covalent bond. That's why according to Lewis-Langmuir adsorption theory, the bond formed between two atoms may be same or different by mutual contribution. Okay. This is, we are dealing with what, children? We are dealing with only mutual. This is what a coordinate covalent bond. This is what a coordinate covalent bond. We are not at all dealing with coordinate covalent bond. Now we are dealing with mutual sharing. Correct? Let us see that how the mutual sharing are going to be takes place. How the mutual sharing of the electron are going to be takes place. Okay, mutual sharing. Mutual sharing of the electron in the Langmuir adsorption, Langmuir, how it is going to be formed. Let us move to the examples. Let us move to the one by one examples, children. First example, let us start with example number 1, homomolecular. Homomolecular means what? Two bonding atoms are same, like the H2, O2, or we can take N2. So here first let us see H2 molecule. H2 molecule. In case of H2 molecule, every hydrogen atom carries one dot. Okay. Every hydrogen atom has one dot, is nothing but what? It contains only one valence electron. Only one valence electron. Another hydrogen also carries one valence electron. They are going to form what? H and H with valence electron will write. Depending upon, we can say that it can also become duplet. This also can become it as a duplet. Correct? This is called as a sharing of electrons. Sharing of electrons, which leads to the formation of what? Hydrogen and hydrogen, they are bonding by a single bond. Hydrogen and hydrogen are bonding by a single bond. We are considering what? Homomolecular. Homomolecular. Let us see that. Another example. Let us see the another example, like the oxygen molecule, O2. Let us write here O2. And we know very well that in case of the oxygen molecule, every oxygen carries, what is the electronic configuration of oxygen? 1s2, 2s2, 2p4 will say. So how many valence electrons will be there? Valence electrons will be 6. Valence electrons will be 6. O and O. Correct? 1, 2, 3, 4. Correct? Exhibited by individual one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct? 5, 6. So here due to this bonding, we are going to get a what? We are going to get, in case of this one, I'll make with the different this one. They are going to form what? By the sharing of the electron, 8 electrons. This also going to get what? 8 electrons. 8 electron. And this is shared equally from both the side, because when one single electron contributed by individual species, one electron shared from one and the other one electron from other, leads to the formation of a single bond. Two electron from individual constituent particle leads to double bond. What will get over here? O, double bond O. And lone pair of electrons will be present as 1, 2, 3, 4. 1, 2, 3, 4. Here I will not write triple bond, it will be confusion. We can write it as like this. We can write it as like this. So it means that whenever we are writing 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So here when we are writing with respect to the O2 molecule, whenever we are writing with respect to what, children? O2 molecule, always we should see that they should carry how many electron? 1, 2, 3, 4, 5, 6. Correct? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 from individual one. This also become octet. That also becomes octet. Same way if we'll take with respect to nitrogen. Here only I'll write nitrogen. N with N. Correct? How many valence electrons will be there? 5. 1, 2, 3. 1, 2, 3. Correct? 1, 2, 3. Then 3 here it will be. Then we'll write here 5. Correct? 5 plus 3 will form what? 8. Correct? 5 plus 3 will form what? 8. Both are going to attain octet electronic configuration. Both are going to attain octet electronic configuration. That's why simply we'll write it as N with N. N with N. How many bond will be there? Triple bond. What I said? Individual atom are sharing one, they will form a single bond. If they are sharing two, they will form double bond. If they are sharing three, they are going to form a triple bond. And here, when they are getting a formation of a chemical bond here, see here, these two, 1, these two, 1, these two, 1. So total we are getting what? 3 bond here. N triple bond N. N triple bond N. These are the 3 examples of what? Homomolecule I said. Homomolecule means what? 2 bonding elements are, or the 2 bonding species are same. That's why they are going to form what? Homomolecule. If it is a heteroatomic molecule, let us move to heteroatomic molecule. Okay. Second example. Heteroatomic molecule. Heteroatomic molecule. Simple example, let us consider water. Examples. Some of the examples we'll see, children, because examples are most important. Water molecule. When we are dealing with the water molecule, what we said that oxygen will be present at the center surrounded by 2 hydrogen atoms. As we know the structure, oxygen is at the center and the 2 hydrogen atoms will be there. 1, 2, 3, 4, 5, 6, 7, 8. Correct? Easy. By knowing the structure, as we have completed this one, in this one, we can write the easily that how to represent them. Hydrogen, and this is oxygen, and this is hydrogen. Correct? We are going to write what on the basis of, we are going to write here only 1, because from both we are going to get what? 1 valence electron, because every hydrogen atom has how many valence electron? Only 1. Whereas oxygen carries what? 6. 1, 2, 3, 4, 5 and 6. Correct? 6. Like this, 1, 2, 3, 4, 5, 6, 7 and 8. 7 and 8. So they are going to form what? Octet. 8 electrons will be there, and these 2 are going to form a duplet. They are going to form what, children? They are going to form a duplet. So like this, we are going to exist with respect to what? Even with respect to organic molecule. When we are dealing with the organic molecule, like the methane. Have you observed that in case of the methane, 1 carbon contain how many valence electron? 4 valence electron. Carbon contain 4 valence electron, and we are writing 4 hydrogen. 4 hydrogen means hydrogen are carrying only 1 valence electron. only one valence electron. That's why when we are representing the formation of a molecule, that is a formation of a covalent bond in methane molecule, we'll write carbon at the center and 4 hydrogen at the 4 corner of a tetrahedron, as we know very well. Correct? 1, 2, 3, 4. This is the individual valence electron carried by hydrogen and the 4 valence electron carried by carbon. Correct? Then they are forming what? 1, 2, 3, 4, 5, 6, 7, 8. So they are going to form a octet. Correct? Here 1, here 1, here 1, here 1. So totally 4 plus 4 we are having 8, and this hydrogen will form a duplet. Correct? So like this, we are going to get the formation of a what, children? Methane molecule. If you are expecting that, how come it is possible in carbon-carbon double and carbon-carbon triple? Carbon-carbon double means what? We are having the example like C2H4. Correct? 2 carbon atoms are bonded by double bond. That means that individual carbon has to share 2 electron. Individual carbon has to share 2 electron. That's why when we are writing with respect to the carbon, we'll write like this: carbon and carbon. Every carbon has 4, this one, the electron. 1, 2, 3, 4. 1, 2, then 3, 4. Correct? Then hydrogen. Hydrogen will be there, which also contain 1 valence electron. I'm representing both the electron with different color, children. 1 electron, and this will also be 1 electron. Correct? 1, 2, 3, 4, 5, 6, 7, 8. So totally they are forming what? Octet. They are forming octet. And this is hydrogen. Duplet. Correct? Now, see here. This is a formation of a 1 bond, and this is a formation of a other bond. So here they are going to get a what? Double bond. One will be the axial overlapping, one will be the lateral overlapping. Do you know? When orbitals are going to overlap, either axial or lateral overlapping. And axial overlapping always leads to what? Formation of a strong bond, whereas a sigma bond, strong bond, whereas the pi bond will be involved with the weak bonding, this one. That's why intermolecular, that is homoatomic molecular and heteroatomic molecular we have represented. Now it is also possible with respect to the molecular ions also. With respect to molecular ions. Third example. With respect to molecular ions also, we can expect the formation of a bond. We can expect representation of a bond like carbonate ion, CO3 2 minus. Carbonate ion. How you are going to write a carbonate ion? Because we are not going to write any lengthy answer over here. That's why you know that every bond will be consist of 2 electrons. That's why go on writing yourself. 1, 2, 3, 4, 5, 6. Because already we are having 7 and 8. This is already balanced. 1, 2, 3, 4, 5, 6. 7 and 8. 1, 2, 3, 4. 5, 6, 7 and 8. Correct? This is obtained by equal sharing of electron. This is also obtained by equal sharing of electron from 1 electron from this, 1 electron from this, 1 electron from carbon, 1 electron from this one. But here there is a what? A double bond. So 2 electrons are going to be shared. 2 electrons are going to be shared. Same way with respect to NH4 plus, ammonium ion. Ammonium ion. Every nitrogen, correct? H, H, H and H. Correct? Every nitrogen. So we can say that during the bonding, because nitrogen contain 5 valence electron, hydrogen contain 1. That's why we are going to get a positive charge on NH4 plus. We'll say that on the basis of individual electron from this side. So like this, we are going to represent on the basis of homomolecular or the heteromolecular or the molecular ion. All these are for what, children? On the basis of Lewis-Langmuir theory. Now the question arises that all these, have you observed that everywhere I'm writing just a round only for 8. It means that It means we can make the conclusion that 8 electrons must be present in a molecule to attain stability. 8 electrons must be present in a molecule to attain stability. Okay, to attain what, children? To attain stability. Now let us see that all the molecule cannot obey octet rule. Certain limitations will be there. Even the molecules are there which do not contain 8 electrons, they are stable. They are stable. Doesn't mean that they are not stable. They are stable. Even they contain more than 8, they too are stable. Even they contain odd number of electrons, even they are stable. But theory is failed to explain. The octet theory is failed to explain why it is so. Limitations of octet theory. Limitations. We'll call it as what, children? Limitations. When we are writing with respect to the limitations, we can say that limitations of octet theory. Is it visible now? Yes. Limitations of octet rule. Correct? Limitations of octet rule. When we can say that limitation, these are the drawback, and every theory has drawback. Without the drawback, no theory can exist. According to the first one, incomplete octet structure. The first one is that incomplete octet. Incomplete octet. One of the example I'll tell you, like lithium chloride. Lithium chloride. Lithium contain 1 valence electron, correct? This is 1. Chlorine contain 7. Correct? They exist together, but lithium is not obeying octet. Lithium is not obeying octet. It is called as incomplete octet. Incomplete octet, but lithium chloride is stable. Lithium chloride is stable. Same way if I am going to write, like beryllium chloride, BeCl2. Beryllium chloride. Beryllium chloride. Correct? When we are writing with respect to the beryllium, we know very well that beryllium atomic number is 4. 1s2, 2s2 will say. Beryllium is what? 1s2, 2s2. That's why when we are writing with respect to the beryllium, I'll write beryllium at the center and 2 chlorine at the adjacent side. Okay, here also we are going to get a bond. Here also we are going to get a bond, but beryllium is not getting 8 electrons. They are containing less than 8 electrons. If I am going to write boron trifluoride, BF3, BF3. Boron is at the center and the 3 fluorine are there, correct? Okay, 3 fluorine, 1 and 1, 1 and 1, 1 and 1. But boron is not, F is attaining 8 electronic configuration, but boron is not attaining. So here we have taken some of the example like lithium chloride. We have taken the example like lithium chloride, beryllium chloride, or boron trifluoride. So here some of the examples I have taken, just 2-3 examples to say that octet rule, even the incomplete octet and they are stable. But octet theories fail to explain. Octet theories fail to explain the reason behind this, why it is so. Octet theories fail to explain. That's why we can say that on the basis of this one, we cannot justify octet theory. The second one is, some of the molecules are there, they are containing odd number of electrons. Second one, odd number of electrons. But they are stable. They are containing odd. They are containing odd means what? On the basis of this theory, if I am going to write as NO, okay? When I am writing with respect to this one, if I am going to write NO, that is a N triple bond O, if I am going to write. Correct? As we are having with respect to the NO molecule, the oxygen will contain what? It contains 4 lone pair of electron, but nitrogen contain 3. Odd number of electrons are there, but they are stable. Okay, they are stable. An O molecule, they are stable. On what basis you are going to justify this answer? Because according to the octet rule, you said that, without this one, without the obeying 8 electron, they cannot become stable. If we are going to take NO2 also and O, correct? NO2. Here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. In case of nitrogen, you can see 1, 2, 3, 4. But the nitrogen contain how many valence electron? It contains 5 valence electron. So one will be present here. One will be present as a odd number of electron. Here also it present as a odd number of electron, but they are stable. Correct? The octet theories fail to explain for this. And the third, this one, the drawback that some of the, the molecule are there which are containing expanded octet form, expanded octet structure. They are containing more than 8 electrons. They are containing what? More than 8 electrons. If we are taking PCl5, correct? Around phosphorus, we are going to write 5 chlorine atoms, correct? They are bonded with what? 5. So here they are going to contain, the phosphorus will get how many electrons? 10. 10 electrons. So it means that they are having expanded. They are containing 10 electrons. Same way, if I am going to take SF6, it contains 12 electrons because every bond will be composed of what? 6 electrons. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. So how many electrons will be carried by this one, the sulfur? 12 electrons. With phosphorus, how many it will be? 10 electrons. That means that octet cannot be applied for all the molecule. Octet rule you cannot apply for all the molecule. You can apply for selected molecule. Correct? And the last one said that this octet rule cannot justify the molecular. We can say that it cannot justify the shape of a molecule. Molecular shape is not explained by what? Octet theory. These are the 4 important drawbacks are there. Do not justify shape of a molecule. Shape of molecule. Shape of molecule. Now the question arises that apart from this octet theory, we need to discuss that what do you mean by a formal charge? We have to discuss one important part of this topic is formal charge. Formal charge. Formal charge Fc is nothing but what? V minus L minus half of S. Simple way, I'll write the formula. Mathematical relation, V minus L minus half of S. V represent number of valence electron. V represent what? Number of valence electron in that individual element. L represent number of lone pair of electron. Lone pair are nothing but what? Which are not involved in bonding. Half of S. S is nothing but number of electrons shared or which are involved in bonding. This is the simplest formula. V minus L minus half of S. V represent number of valence electrons. On individual element. L represent all are number only, not a pair. Number of lone pair of electrons, and S represent number of shared pair of electrons. Shared pair of electrons. V minus L minus half of S. Let us move to the example one by one. Quickly we'll go to the example, children. V minus L Shall I write here? Fc is equal to V minus L minus half of S. We know the resonating structures. Yes, already we have read in this one, but even though we are going to discuss resonating structure in the next one. Ozone molecule. Well, let us take the first example, O3 molecule, that is ozone molecule. We are going to represent by ozone as O double bond O and single bond. Correct? 1, 2, 3, 4, 5, 6, 7, 8. Correct? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It will be 7 and 8. Correct? What is the charge carried by this oxygen? What is the charge carried by this oxygen? And what is the charge carried by this oxygen? We have to calculate. We know very well that even they can be represented as O with O and double bond O. That's why all together we will write the resonating structure of the ozone as like this. Correct? Double bond will be like this. Correct? We are going to write. Now we'll see that what is the individual charge. Afterwards, you can write the same. Let us write the name one by one. This will write it as 1. This I'll write it as 2. This I'll write it as 3. Correct? Charge on, formal charge of O. What number? 1. Correct? We'll write the same. Number of valence electron in oxygen will be 6. 1s2, 2s2, 2p4 minus L. How many valence electrons are, lone pair of electrons are there? 4. Valence electron 6, lone pair of electron 4. Minus half of, correct? Shared pair of electrons also. With respect to this one, we are going to write it as what? 4. 1, 2, 3, 4. 4 have been shared. So here we can write it as 6 minus 4 minus 2. Answer will be 0. Answer will be 0. Therefore, no charge carried by first one. Same way we'll write formal charge of oxygen, second number. This is second number. We'll write it as number of valence electron will be 6. And this one, the lone pair of electrons are 2 minus half of shade. How many bond are there? Like this you can count. How many bond are there around that element? Every bond 2 electron. Number of bond multiply by 2. 1, 2, 3, 4, 5, 6. 6 we can write it as 6 minus 2 minus of 3. Correct? Minus of 3. It will become it as what? Plus 1. The charge carried by second one is plus 1. Same way, formal charge of oxygen of number 3. Correct? 6 it will be. One number of valence electron will be 6. How many lone pair are there? 6 are there. Minus half of shared pair. Only single bond, it will become it as a 2. Correct? It will become, what will get the answer it as? Minus 1. Therefore, when you are writing the resonating structure or when you are writing the formal charge, the oxygen carried by double bond, this is no charge at all. This will be 0. And the second are getting the charge as plus 1. And the third are getting the charge as minus 1. As a whole, for a molecule, the total number of positive charges and negative charges are equal. That's why here also we can write it as a 0. And for this triple bond we can write it as plus 1, double bond and single bond. This we can write it as minus 1. This is one of the simplest way to calculate the formal charge. Same way we can calculate the formal charge even with respect to what, children? Carbonate ion. One more example, so we'll see. Remaining examples you need to solve yourself. Carbonate ion. How you are going to write the carbonate ion? C double bond O, O and O. We want to prove that really is it true that they are carrying minus 1 and minus 1. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is already balanced. Don't write any lone pair of electron. 1, 2, 3, 4, 5, 6, 7 and 8. Now the question arises that what to write on this, what to write on this, what to write on this, what to write charge on this. Formal charge, okay? V minus L minus half of S will calculate. Formal charge, okay? Formal charge on carbon only will start from carbon. Correct? Carbon 1s2, 2s2, 2p2. So here it will be 4. Number of valence electron will be 4. L will be 0 minus half of. Correct? It will be 1, 2, 3, 4. 4 bond are there. Electron will be 8. 4 minus 4 will be 0. That's why no charge carried by this. This will be 0. This will be what? 0. No charge. Same way, if I'll write formal charge on double bonded oxygen. Double bonded oxygen. Correct? I'll take it as what? How many valence electrons will be there on oxygen? 6. Lone pair of electrons, how many are there? 4. Minus half of. How many are there? 4. Correct? So here we can write it as what? 6 minus 2 it will be. Minus 4 minus 2. Again answer will be 0. Therefore, no charge carried by this. This will also be 0. Now we'll calculate for one oxygen. Other will be same. Correct? Formal charge on single bonded oxygen. Single bonded oxygen. Single bonded oxygen will be 6 minus 1, 2, 3, 4, 5, 6. 6 minus half of. How many valence electron? 2 are there. Correct? 2 are there. That's why when we are writing with respect to this one, 6 minus 6 minus of 1. So answer will get it as what, children? Minus 1. Therefore, this oxygen also carries minus 1 charge. This oxygen also carries minus charge. As a whole, carbonate can be written as C double bond O, O with a negative charge and O with a negative charge. Same way, you try to answer for NO3 minus. Even you try to answer for NH4 plus. Many of the examples are there where we can identify that as we are writing on the NH4 plus we'll write, but actually positive charge is carried by nitrogen. Formal charge we can say. Formal charge carried by nitrogen is plus, that you need to calculate individual one, children. When you are calculating individual one, then only you can understand that on the basis of which concept we can write the charge carried by them. The charge carried by the respective this one. Okay. The next is related with what? Resonance. What do you mean by resonance, children? Resonance are representing the delocalization of pi electron. Okay. What do you mean by resonance? Resonance. To make the molecule to write a different contributing structure to attain stability is called as resonance. Is called as what, children? Resonance. That's why whenever we are writing with respect to the resonating structure, we should see that the contributing structure must have same position. Shall I write here? The contributing structures must have same position. In case of the resonating structure, what is the condition? That the contributing structure must have the same position of what? Atoms. Same position of atoms. And all the contributing structure must have almost a similar energy. Almost so what we can say, to get a resonating structure, they must have almost a similar energy. And here, and every contributing structure must have same number of paired and unpaired electrons. So what we can say that to get a resonating structure, the contributing structure must have same number of paired and unpaired electrons. Paired and unpaired electrons. They must have what? Same number of paired and unpaired electron. And the last is the contributing structure should not have like charges together, close to each other. Should not have contributing structures should not have the contributing structures should not have the like charges on the adjacent atom. Should not have 1 minute. Should not have similar charge on adjacent atoms. These are the 4 important conditions are there to represent a molecule resonating, or we can say that all these resonance, why it has happened? It is a delocalization. Delocalization of pi electrons are called as what, children? It is called as resonance. And to get a resonance, contributing the structure must have same position of atoms. Second one, they should have almost similar energy, means contributing structure. Contributing structure must contain same number of paired and unpaired electron, and they should not have, we said, they should not have similar charge on adjacent atoms. On adjacent atom, because when similar charge are there, they are going to be repel. One side should be positive and other side should be negative. Then only we can say that by changing the structure, or sorry, by changing the position of the double and the triple bond, or the delocalization of pi electron, all these reasons are to make the molecule stable. Because altogether what we are studying here, children, we are studying with respect to resonating structure. We want to make the molecule stable. We want to make the molecule stable. If we are going to write with respect to carbonate ion, C double bond O, O with negative charge and O with negative charge. You can see here, both are not on the adjacent atom. They are different. So we can write this resonating structure as even C with a negative charge. This can become it as a double bond. This can become it as a negative charge. Or we can write it as C with a double bond O. Already have written. No? Okay, let it be. C with this one. Double bond O. I can take this one as negative. This I have taken already. This will take it as a negative. This also will take it as a C with the negative, C with the negative, and double bond. Okay. So different resonating structures we can write. Same way we can write simple example we have written many times with respect to benzene. You may be remembering that alternate single and double bond, but no position is permanent. Correct? No position is permanent. That's why whenever you are writing a resonating structure, we will write that there will be a delocalization of pi electron around this one. Correct? That's why I said that instead of writing this complete structure, we can represent the delocalization of pi electron by a dotted line. If we are writing sulfur dioxide, we'll write it as S double bond O with O. Even we can represent this by what? S double bond O and O. Correct? Here 1, 2 are there. 1, 2, 3, 4, 5, 6, 7, 8. This we can write it as 1, 2, 3, 4, 5, 6, 7, 8. Whereas here sulfur 8, 2. Here will be 2. 1, 2, 3, 4, 5, 6. We can change. Or we can write in a simple way as S with O and O. Double bond. Correct? This is the best way to represent. So double bond position is not permanent. Either the double bond is between sulfur and this oxygen or sulfur and this oxygen. All together, the main reason that we want to get a stability. Our whole topic aim is only one, children. Our whole topic aim is only one, to get a stable molecule. Okay. much it is possible. Half of this one, the topic I have completed. We'll see in the next class, either this one, depending upon the situation. We'll see that remaining topic can be completed. Okay, we'll wind up here, children. Thank you, one and all.